Welcome back to another video. Today's video will be short and interesting. We'll discuss about integration of Kubernetes with Jenkins, GitHub, Docker Hub and Docker. We will be doing a master-slave setup today. Every engineering student knows master, slave, but haven't implemented it with real use case. We'll see my system setup first, and then a practical implementation. So every system have some hardware which I too have. It have some RAM, CPU, and storage. I have Windows 10 operating system as a bare metal operating system. I have installed a software named Oracle VMware. It allows me to install virtual machines with complete isolation. On the top of VMware I have installed Red Hat 8 OS. It have its own network card. I also have Minikube installed in virtual machine. Minikube is a single node master and slave. That means one system is master, as well as a slave. I also have a Docker setup on top of Red Hat 8 OS, where I can launch multiple containers, that is, a fresh operating system. I have also installed Jenkins in my Red Hat 8. As everything here is isolated, each one have its own IP addresses. This is the IP address of Red Hat 8. Note, it ends with 106. Similarly, this is the IP address of Minikube. I also have internet connectivity provided here to all the machines, also they all are interconnected, as they all are in same LAN. I am also using GitHub and Docker Hub so that maximum process can be automated. And finally, this was a short discussion about my setup. Before jumping into implementation part, let's first go through master-slave setup. So we should have a master, a slave, and an admin. Admin tells master his requirements, accordingly master assigns the tasks to the slave and manages each slave. So in our case, as an admin we will tell master to manage our website and its server. So that whenever the client visits the site, it should never show downtime. So for achieving zero downtime, I am using Kubernetes. It have a load balancer, which internally manages all the incoming traffic. Minikube is a tool that makes it easy to run Kubernetes locally. Minikube runs a single-node Kubernetes cluster inside a virtual machine. Now let's implement Kubernetes setup locally. So let us begin. This is my Red Hat machine, and this is its IP address, ending with 106, which we already discussed. Currently I do not have any running containers. These are the images stored locally. You can also see that none of the container is in stopped state. Container or image is nothing but an OS in Docker world. So, this is my Windows, and we should keep exploring. This is my GitHub's remote repository for my website's web page. This is my local Git repository. This is my same web page. This is my Jenkins installed in Red Hat, you can see its IP address. This is Docker Hub where all the images can be stored remotely which are used by Docker. This is my images with the web page and a web server configured in it. This is the image which should be used by the admin, managing master. Now please listen carefully, else you won't get anything in this video. I have configured a pipeline such that from now whenever I will do the local commit on my web application, the code will get pushed to GitHub automatically. Once the GitHub repository gets updated, GitHub will trigger my already configured Jenkins job. This job will configure a new operating system for my admin. This operating system will have Jenkins installed in it, with all the rights required to manage master, which is Minikube in our case. As OS is new and Jenkins is freshly installed, my job will send the unique system-generated password to admin for first login in Jenkins. Later admin needs to reset password for future logins. Additionally, when some changes are made in local repository, the new image of operating system gets generated and is pushed on Docker Hub automatically. And then by one click, admin can make it available for clients. That too is pushed on top of Kubernetes. Kubernetes have multiple advantage for the same. You can see that my web page is updated 17 hours ago. Now I will update some part of code and will commit it locally. I have updated the color, now we'll save it. Saved. As soon as I save it, my local Git will come to know that something is changed. See, the notification comes in right top corner. I will now stage the changes. We'll add some description and we'll commit it. Once I commit it, it gets pushed automatically, as I explained before. See, it pops that we are pushing. And it is pushed successfully. Now after refreshing page, you can see the changes. As I said that it will trigger the job once the GitHub repo is updated, see, the job started running. Now, as explained, this job will create and run new container or OS. You can see that soon the OS comes up. And here it is up. And it is running too. Now we will go to our mailbox and we'll wait for password mail to reach us. And finally we received the password to log in into Jenkins. As you can see that I have exposed 8080 port of this container and have done padding to 82 port. So now we'll visit to 82 port and can log in. Here the Jenkins comes up. Copied system generated password. And logging in. Logged in. Now we'll start with Jenkins. We'll update password. After updating password we need to log in again. And logged in with new password. Now before creating a job, let us know our Minikube IP address. Let us first know the status of Minikube. As Minikube is stopped we need to start it first. Now it is started. Now let's see the status again. We can see Minikube is running. Now we'll see the IP, and do note the IP address. This the IP address and port where the website will work when admin will start Kubernetes services. Now I will quickly create job and will configure it as an admin. I am just writing code to start the services of Kubernetes. It required a YAML code. Now I will run the job. Once I run the job, Minikube will download the image from Docker Hub and will start its services. And once the services are started, there will be zero downtime. This is what Kubernetes does for us. It handles the slave failure. Even if we update the code of web app, it will smoothly update it. You can see that now our website comes up. You should note this IP address. Now I will take you to Docker Hub. On Docker Hub the images are stored with their versions. Yet there are no versions here. So now I will update my web page from local repository and you can see that the new version of the image will come up. So I have updated the color to green. Now we'll commit it locally and we'll wait for new version comes up. I have pressed the commit button. You can see it's processing and will be pushed soon. Now we will go to Docker Hub, and once the new version will come up we will update it, and clients can see the new website. It is refreshing. Have a look, new version comes up on Docker Hub. It is v3. This command will tell master to update the website with v3. Our website will have zero downtime. Now by running this job the new version will be updated on the top of Kubernetes. See the new website comes up. You can see that the old users who were working with the website won't see new page until they are in that session. This is called smooth rollout. And Kubernetes plays very smart role in the competitive world. The key of this video is that the way we automated the process from local commit to configuration. Thank you.